So today I'm going to review the practice questions from the factoring worksheet for Emathinstruction. The first question says, rewrite each of the following binomials as a product of an integer with a different binomial. So pretty much we're going to use the GCF method because each of these terms in every expression has a common factor, and we are going to pull that GCF, the greatest common factor, out and then write the remaining terms. That's a strategy you use when you are factoring and all of the terms in the expression have common factors. So 10x minus 55. Ask yourself, what can go into 10x and 55? 5. So the GCF is 5. And that's what we write outside the parentheses, because we're pretty much doing the distributive property backwards. We're trying to find out what is that term on the outside that we distributed into the parentheses to get 10x minus 55. Since 5 is a common factor between the two terms, it means that we must have multiplied 5 into the parentheses to get 10x minus 55. So now you think, what do I need to multiply 5 by in order to get 10x minus 55? Well, 5 times 2x is 10x. And to get a minus 55, I must have multiplied 5 by minus 11, because 5 times negative 11 is negative 55. So we're done. If we multiply 5 times 2x minus 11, we will do 5 times 2x, which is 10x, and then 5 times minus 11, which is minus 55. So we know that the expression that we just wrote is equivalent, and it's also factored in factored form. So let's do B. So you remember, you think, what can go into both 24x and negative 40? 2, but 2 is too small. We want the greatest common factor. 4 can go into both. I believe 4 is our greatest common factor. And if for some reason you make a mistake and you actually don't use the greatest common factor, we will be able to recognize that and just factor again. So let's use 4. And now we think, 4 times what will give me 24x minus 40? Well, 4 times 6x, that will give me 24x, because if you think about it, 4 times 6 is 24. And 4 times 10 is 40, so I'm going to put minus 10. So you see, 4 is not the greatest common factor. How do we know that? Because 6x minus 10 still has a common factor. What can go into both 6 and 10? 2. So I can factor out another term, another common factor, which is 2. So my GCF is actually 8. 4 is actually not a GCF at all. It's just a CF. So I'm going to use 8 instead. So now I think, 8 times what will give me 24? 8 times 3. So if I multiply 8 times 3x, I'll get 24x. And if I multiply 8 times 5, I'll get 40. So the GCF is actually 8, And our factored form of 24x minus 40 is 8 times 3x minus 5. How do I know I'm done? Because 3x minus 5 does not have any common factors between the terms. Let's do C. Maybe you want to try C first to see if you understand. So pause the video and try C and D, and then I'll review it with you. If you're just copying and listening, that's not enough to really understand the math. So it's very important that you try and practice first. Okay, so let's do C. We have 6x minus 45. So you think, what can go into 6x and 45? Not 2, 3. I wonder if 6 can go into 45. I can always use my calculator and divide. I can find my calculator. I got it. 45 divided by 6. Hold on, technical difficulties. 45 divided by 6 is 7.5. No good. So I'm thinking 3 is my GCF. So we're going to put 3 on the outside and think, 3 times what will give me 6x? Well, 3 times 2 is 6. So 3 times 2x will give me 6x. And 3 times what will give me 45? Now, if you're not sure, just grab your calculator and divide. 45 divided by 3, 15. So the factored form of 6x minus 45 is 3 times 2x minus 15. I know that I'm done because 2x and 15 do not have any common factors. And let's do D. 18x and 9 have a common factor of 9. The GCF is 9, so we put 9 on the outside. 9 times what will give me 18x? 9 times 2x. 9 times what will give me 9 again? 1 minus 1. So the factored form of 18x minus 9 is 9 times 2x minus 1. Number 2, rewrite each of the following binomials as a product of its GCF along with another binomial. So we're going to use the same strategy, the GCF method, and we will get a term on the outside and another binomial inside the parentheses. So 2x squared minus 8x. Do you notice something a little different about this expression? That both terms contain a factor of x. So what could go into 2 and 8? 2. What can go into x squared and x? X. So this GCF is 2x. And that's what we put outside. And now you think, what can we multiply 2x by to get 2x squared minus 8x? So 2x squared just has an extra x compared to 2x. We're multiplying by one more x. So 2x times x will give me 2x squared because x times x can be written as x squared. And 2x times minus 4 will give me a minus 8x. And we're done. Let's double check. What is 2x times x? 2x squared. And what is 2x times a minus 4? Minus 8x. So we know we're right. That's my lefty check because I'm a lefty. Okay. Let's do B. So the GCF between 6x and 27. It's not 2. 3 maybe? I don't think 6 can go into 27 evenly. Let's try 3. And once again, if you choose the wrong GCF, maybe you chose a common factor instead of the greatest common factor, it's okay. Because in the end, when you are done, you can see if there's still any common factors. So let's put 3 on the outside. 3 times what will give me 6x? 3 times 2x plus 3 times what will give me 27? 3 times 9. And if you're not sure, you can always divide 27 by 3 and you will get 9. So try C and D. See if you can do it on your own. And then I'll review it with you. So C says 30x squared minus 35x. So what GCF did you write? Well, I think that the GCF is 5. And we also have x terms, so we will say 5x. So what do we multiply 5x by to get 30x squared? Well, 5 times 6 is 30, and x times x is x squared. So we're going to put 6x minus 5 times 7 is 35, and we don't need to put another x because then we'll get x squared, and we just want 35x. So we're done. Did you get that? Of course you did. And if you didn't, just review what you did to see where you made a mistake and fix it. Mistakes are good. That's how you learn. Hello. Let's do D. What can go into 24x cubed and 20x squared? 24 and 20. There's a lot of numbers that can go into both. But what's the greatest number? Is it 2, 3, 4? I think it's 4. So our GCF definitely contains a 4. Now we have x cubed and an x squared. So I'm sure you agree that x can go into both. But is that the greatest? Well, let's see if you expanded x cubed. You would get x times x times x. And if you expanded x squared, you would get x times x. So what factors are in both x squared and x cubed? Oops, that's way too big. Well, it's x times x. Both x cubed and x squared contain x squared. So that's the GCF. So our GCF for this problem is 4x squared, because 4x squared can go into 24x cubed and 20x squared. 4x squared goes on the outside. And now let's think. What do I multiply 4x squared by in order to get 24x cubed? Well, 4 times 6 is 24. And x squared times x is x cubed. What do I need to multiply to get plus 20x squared? Plus 5. No more x's. I already have my 4x squared times 5 will give me 20x squared. So we're done. And it looks like I chose the right GCF because 6x plus 5 does not have any common factors. Rewrite each of the following binomials as a product of a conjugate pair. I'm going to do A with you, and then I'll show you what a conjugate pair looks like. Or I can just tell you right now. If you look back at the notes, at the exercises, they show an example of a conjugate pair, and it just says x minus A and x plus A. So a conjugate pair almost looks identical except for the operation are opposite. Negative, minus for one and a plus for the other. This can also be called the difference of perfect squares strategy because x squared is a perfect square, 121 is a perfect square, and the difference is used with the subtraction sign. So just like we had the GCF method, this is called the DPS method. Difference of perfect square. When you have a difference of perfect square, you know your answer is going to have two binomials. Just like with GCF, you know that you're going to be pulling out the GCF to the front and you'll have the remaining factors in parentheses. With the difference of perfect square method, you know you're going to have two binomials. So it's very important to look at your expression and determine which strategy is best. This is life skills, people. When you have a problem, you look at the problem first and determine what's the best strategy to solve the problem. So, since my first term is x squared, I know that x will be the first term in both my binomials. Because if we were doing this in reverse, we would use a distributive property, and our first step would be x times x. Next, I have a negative. How can I multiply two numbers and get a negative answer? It means one of them has to be positive and the other has to be negative. So I'm going to fill in a plus and a minus as my next step. Now I'm going to think, how do I get 121? Well, 121 is a perfect square. That means that a number squared gives me 121. What is that number? If you're not sure, grab a calculator and take the square root of 121. You will get 11. So that means an 11 goes here and 11 goes there. So those are my conjugate pair. That is my conjugate pair. X plus 11 times x minus 11. Let's just double check to make sure. We would do x times x. This is our check. I like to put a little question mark there to show that we're checking. Is it equal? You know? So x times x is x squared. X times negative 11 is negative 11x. X times x is positive or plus 11x. And a positive 11 times a negative 11 will give me that negative 121. These two terms in the middle are called like terms. And what happens when we combine a negative 11x and a positive 11x, or when we add them, we get 0. So these two terms are equivalent to 0. So what are we left with? x squared minus 121, we are correct. And that always happens when you multiply a conjugate pair. If they weren't a conjugate pair, we would get a trinomial. But because they're a conjugate pair, the two middle terms cancel and give you 0. And you're left with a difference of perfect squares. Let's do 64 minus x squared. Because it's a difference of perfect square, 64 is a perfect square, and so is x squared. I know that my answer is going to be 2 binomials. The square root of 64 is 8. So the first term should be 8. In order to get a negative, both my symbols should be different, a positive and a negative. And in order to get x squared, I must have multiplied x times x. And I'm done. You can try C and D, and then let's see if you did it right. So C, 4x squared minus 1. 4x squared is a perfect square, and so is 1. So I know I'm going to use the difference of perfect square strategy, and my answer will have 2 parentheses, 2 sets of parentheses. 4x squared. What's the square root of 4x squared? Or what do I multiply by itself to get 4x squared? Well, 2 times 2 is 4, and x times x is x squared. So my first term in both the parentheses would be 2x. I can put a minus and a plus. It really doesn't matter if I put the plus first and then the minus. That's the commutative property. And to get a 1, I have to multiply 1 and 1. So there's my conjugate pair. 2x minus 1 times 2x plus 1. Did you get that? Of course you did. And if you didn't, that's fine. Just make sure you know what your mistake was. So here we have 25x squared, which is definitely a perfect square. And 1 over 9 is also a perfect square. Even though it's a fraction, we love fractions, remember? So what do I multiply 25? Sorry, what is the square root of 25x squared? 5x. And what is the square root of 1 over 9? Well, what's the square root of 1? 1. And what's the square root of 9? 3. So the square root of 1 over 9 is 1 over 3. Because 1/3 squared is 1/3 times 1/3, which is 1 over 9. So in my binomials, I need a negative 1/3 and a positive 1/3. And I'm done. We write each of the following trinomials as a product of its GCF and another trinomial. So we're going to use the GCF method, not the difference of perfect square method, because we would need only 2 perfect squares being subtracted. So what can go into 4x squared, 12x, and 28? I'm thinking 4, not 4x, because 28 does not have an x term. So the GCF is 4. 4 times what will give me 4x squared plus 12x plus 28? I'm just going to divide each of those terms by 4. So 4x squared, sorry, I just need to multiply 4 by x squared plus 3x, because 12 divided by 4 is 3, plus 7, because 4 times 7 is 28. 28 divided by 4 is 7. And I'm done. Let's do B. What can go into 6x squared, 4x, and 10? 2. So we'll put a 2 on the outside and the remaining factors inside. 2 times 3x squared minus 2 times 2x plus, 2 times what will give me 10? Well, 10 divided by 2 is 5. So there you have it. A product of a GCF and a trinomial. Let's try C and D. Pause it, try it on your own, and then press play. So now, with 14x cubed minus 35x squared, plus 35x squared minus 7x, what can go into all three terms? 7. Right? No, I forgot about the x's. This one's different. Every term has at least one x term, x factor. So our GCF is not only 7, it's 7x, because 7x can go into 14x cubed, it can go into 35x squared, and it can go into minus 7x. If you forgot and you only factored out a 7, you would know that you forgot the x when you were done, because every term in your trinomial will still have an x. And you would just factor it out at the end. It's okay. So 7x times what will give me 14x cubed? Well, 14 divided by x is 2. And x cubed divided by x is x squared. Also, x times x squared is x cubed. 7 times 5 will give you 35. And we just need one more x. 7 times 5x will give me 35x squared minus 1, because 7x times 1 is 7x. Now let's do D. What can go into all three of these terms? I think it's 5x. Is that what you put? And what did you put inside? Well, 20 divided by 5 is 4. And I need an x squared times x to get me x cubed. Minus, how do I get minus 5x squared? What do I multiply 5x by? Well, I already have a 5. So that's 5 times 1. And I just need one more x. So it's a 1x, or just x, plus 5x times what will give me 15x? 5x times 3. And we're done. Completely factor each of the following binomials using a combination of GCF factoring and conjugate pairs. So let's use the GCF method first. What can go into both 6x squared and negative 150? 6. So we're going to write our GCF is 6. So 6 goes on the outside, and we have to put the remaining factors in the parentheses. So 6 times x squared minus, 150. That's a big one. Let's do 150 divided by 6. 25. Now we can factor again, because one of our factors can still be factored. X squared minus 25. That's a difference of perfect squares. And we're going to factor it into a conjugate pair. So we bring down the 6. Don't forget the 6. It's still a very important factor. And if we don't write the 6, our answer is no longer equivalent to the expression we started with. So I set up my two parentheses because I know a difference of perfect squares when factored gives me two binomials, a conjugate pair. And I know that x and x should be first. That's how I get the x squared. I know my symbols should be a plus and a minus. And in order to get 25, the square root of 25 is 5. And we're done. Next, let's do B. What can go into both 36 and 4? 4. So 4 goes on the outside. And we think, 4 times what will give me 36? Well, I could just go to my calculator. 36 divided by 4 is 9. And then how do I get a minus 4x squared? Well, minus 4, that's minus 1, because 4 times 1 is 4. And I just need an x squared. Now I have to factor the difference of perfect squares. 9 is a perfect square, and so is x squared. So I bring down my 4. And now I think, what is the square root of 9? 3. So I put a 3 and a 3 in the front of both binomials. And then I put different signs, plus and minus. And I have to put x and x to get x squared. Once again, try C and D. See if you get the right answer. Practice makes perfect, especially when you have to take your exam. Okay, what can go into 28x squared and 7? The GCF is 7. Did you put 7? So we write the 7 on the outside and our binomial on the inside. 7 times what gives you 28x squared? Well, 28 divided by 7 is 4x squared. And in order, 7 divided by 7 is 1. So now we have a difference of perfect squares again, 4x squared minus 1. So I bring down my 7 and I write my 2 sets of parentheses. The square root of 4x squared is 2x. Or 2x squared is 4x squared. I put my plus and my minus, and I put my 1s, because the square root of 1 is 1. Did you get that? All right, let's try the last one for this one, this row. 27x cubed minus 12x. What can go into both? I think it's 3. Let's try it. What'd you say? I forgot the x? I sure did. How do we know that the GCF has to contain an x? Because both terms have a factor of x. So our GCF is 3x. What do we multiply 3x by to get 27x cubed? 9x squared minus, what do we multiply 3x by to get 12x? 4. And now we have a difference of perfect squares. Bring down your 3x and set up your 2 sets of parentheses. The first term in both parentheses will be 3x, because 3x times 3x is 9x squared. We'll put different signs, and the square root of 4 is 2. And we're done. All right, let's go. What can go into 80 and 125? I'm going to use my calculator for this one, just to double check. 80, whatever it is, it should end with a 5, because we have 125. 125 divided by 8. That didn't work. 125 divided by 4. That didn't work. 125 divided by 125 divided by, let's start with 5. 5. 5 times 25. 25. So I can do 80 divided by 25. Does that work? No. 5, 5, and 5. 80 divided by 5 is 16. So my GCF is 5. GCF is 5. Did you see how I used my calculator to help me get through that? Please use your calculator to help you get through this. So we put 5 on the outside. 5 times what gives me 80? 5 times 16 minus 25x squared. Now we have a difference of perfect squares. So I set that up. Square root of 16 is 4. Square root of, put my plus and my minus, square root of 25x squared is 5x. Next, the GCF is 2x. Write that on the outside. 2x times x squared will give me 2x cubed minus 2x times 100 will give me 200x. Now I'll use the difference of perfect squares method. Put my x's, my plus, my minus, and tens, because 10 times 10 is 100. Let's do G. We're going to go to 8 and 512, probably 8. I'm going to need my calculator in a second. So 8 times x squared gives me 8x squared. And 512 divided by 8 is 64. So now I use the difference of perfect squares method to get my conjugate pair. Put my x's plus 8 minus 8, because 8 times 8 is 64. And h, what's my GCF? We're going to go into both 44 and 99, 11. And I have an x term. So I'll put 11x on the outside. 11x times 4 minus 9x squared. Yep. So now we do 11x. Set up the GCF, the difference of perfect square strategy. So I need a conjugate pair. I know I'm going to have 2's because the square root of 4 is 2. Put my plus and my minus. And the square root of 9x squared is 3x. When completely factored, the expression 48 minus 3x squared is written as. Now with multiple choice, sometimes you want to work out the problem and then check to see if your answer is there, which is great. Or sometimes you can just look at your choices, eliminate choices that you know are incorrect, and narrow it down to the correct answer. That's a good strategy, especially if you're running out of time and you need to quickly determine the answer for a multiple choice. So all 3 choices have 3's as the GCF. So that's good. But after that, it gets really weird. Let's look at choice 1. 48 divided by 3 is 16. So I know that it can't be choice 1 because there's too many 16s in here. That is definitely not the right answer. Let's look at choice 2. Choice 2 says the x's are first, and then they also have 16s. This is going to be wrong too, because when you multiply and you distribute, you're going to be multiplying 16 times 16, which is going to give you a high number. And all we want is a 48, people. Now let's look at 3 and 4. I can already tell the answer is 4 and not 3. The only difference between 4 and 3 is the location of the x versus the 4. And in our question, the number is first, and then the variable is the second term, is in the second term. So if we were to check this, 4 times 4 is 16, and x times x is x squared. And then multiply by 3, we would get 48 minus 3x squared. Which of the following represent the greatest common factor of the terms 4x squared y to the 6th and 18xy to the 5th? I'm just going to rewrite them over here so I can see. 4x squared y to the 6th, 18xy to the 5th. So the greatest common factor, what's the greatest term that can go into both of these? What do you eliminate right away? Choice 1, too high. Where are they going with that 36? 36 can't go into 4, nor can it go into 18. You know they multiplied instead of divided. Now, is 4 the GCF of 4 and 18? Well, I know 4 times 4 is 16, so I know 4 cannot go into 18. So it's not choice 2 because 4 is not the GCF. So now let's look at choice 3 and 4. We know the 2 is correct because 2 is the GCF of 4 and 18. But let's look at the x squared and the x. Here we have x squared and x. What can go into both? X. X cannot go into x. Sorry, x squared cannot go into x, but x can. And can y to the 5th go into y to the 5th and y to the 6th? Yes, it can. I'd like to show you one more way you can do this problem, just to see if it makes a little more sense. You can write the prime factorization of both. So 4 would be 2 times 2. X squared would be x times x. Y to the 6th would be multiplying 6 y's. 1, 2, 3, 4, 5, 6. 18 would be 2. Let's see, 18 is 6 times 3, which is 2 and 3. Okay, 2 times 3 times 3. X is just x. And then we have y to the 5th, which is 5 y's. 1, 2, 3, 4, 5. So now that the expressions or the terms are expanded and you can see all of the factors, how do we determine the GCF? You just have to see which ones are in both. They both have a 2. They both have 1x. And they both have 5 y's. What was that? They both have 2. They both have an x. And they both have y to the 5th. Do you like that strategy? Never fails. Which of the following is not a factor of 6x squared minus 18x? I think I'm going to factor this one. What can go into both? 6x. 6x times x will give me 6x squared. And 6x times 3 will give me 18x. Now, this 6 can be rewritten as 2 times 3, right? So if we really want to break it down all the way down to the prime factors, we would write 2 times 3x minus x, times x minus 3. So those are my factors. So which of the following is not a factor? Well, x minus 3 is definitely a factor. Okay. 2 is definitely a factor. It's right there. I don't know about that 12, but x is definitely a factor. I don't see a 12 anywhere, people. 12 is definitely not a factor. There's no way I could multiply any of these factors to get a 12. Which of the following prime numbers is not a factor of the integer 330? So to find this out, let's do the prime factorization of 330. There's a 0 at the end, so I know it's a multiple of 10. 10 times 33 gives me 330. 10 can be factored into 2 times 5, and 3 can be factored into 3 times 11. So my prime factorization is 2 times 3 times 5 times 11. Let's see. Not. Do y'all use that strategy where you circle important words? So 11 is, 3 is, and 5 is. So 7 is not. The area, only 3 more left. This is so much fun. The area of a rectangle shape is given by the product of its width and length. The area of a particular, the area of a particular, let me make this a little smaller. The area of a particular garden is given by 5x squared minus 35x, and the width is given by 5x. Then find an expression for the garden's length. Whenever they start talking about shapes, people, draw it. If you're like me, you're a visual learner. So I'm going to need a rectangle, and I'm also going to need some space. Okay, here's my rectangle. I know the area is length times width, which is 15x squared minus 35x. I also know the width is 5x. We need to find the length. So if we know the width is 5x and the area is 15x squared minus 35x, and you multiply length times width to find area, what do we do to find the length? We divide. Or we're going to figure out what do we multiply 5x by to get 15x squared minus 35x. So let's factor it. 15x squared minus 35x can be rewritten as 5x times something. 5x times 3x will give me 15x squared minus 7. So the length is 3x minus 7. The volume of a particular rectangular box is given by the equation V equals 50x minus 2x cubed. The height and the length of the box are shown in the diagram. They gave us our picture. Find the width of the box in terms of x. Recall, that volume equals length times width times height for a rectangular box. So we multiply 2x times x plus 5 times something else, and that will give us 50x minus 2x cubed. How do we find out what's missing? There's a few ways we can approach this. Which way would you like to do? I think we can factor 50x minus 2x cubed. That's a good strategy. What can go into both 50 and 2? 2x. And what do we multiply 50x by? 25 minus x squared. And then this is a difference of perfect squares. So we'll get 2x times 5 minus x times 5 plus x. So there we could see our missing dimension, because you can rewrite x plus 5 as 5 plus x. So the missing factor is 5 minus x. So the width is 5 minus x. A projectile is fired from the ground level such that its height, h, is a function of time, t. It's given by h equals negative 16t squared plus 80t. Written in factored form, this equation is equivalent to, well, let's factor, shall we? Negative 16t squared plus 80t. I notice that all of our choices have negative GCFs factored out. So let's think. What can go into both negative 16 and 80? I have a feeling it's negative 16. But let me check. 80 divided by 16 is 5. So negative 16t is our GCF. What do we need to multiply negative 16t by to get negative 16t squared, a t? And what do I need to multiply negative 16t by to get a positive 80t? Well, a negative times a negative will get me a positive. And I just divided and I got 5 over there. So the answer will be choice 3. And we're done. I hope this was helpful.